Well, thank you guys for coming to our event here. It's our second of our series, Ask Softcrylic Anything. As you guys know, they're kind of based off of the Microsoft events, Analytics in a Day, and Dashboard in a Day. We've been putting on a lot of those as a partner of Microsoft and thought it'd be nice to have people be able to ask their own questions, or we can address as a company and with our subject matter experts questions that we hear or we see in the chat that maybe not everyone hears get addressed or wants further clarification. So throughout this webinar presentation, if you have questions that come up or things that you want addressed or follow-up questions throughout, throw it in the chat, throw it in the Q&A, and we'll get to that here. And if we do not, we'll follow up via email or in a blog to make sure that it does get addressed. My name is Sammy Anderson. I'm our marketing coordinator here at Softcrylic. I'll be kind of moderating, leading the discussion today surrounding Azure Synapse Analytics. I don't know if you guys want to do a brief introduction here quickly before we get into our first question.
Yeah, let's do a quick intro.
You can kick it off, Corey.
Okay, all right. Well, hello, everybody. I am Corey Turner, and I lead the data viz practice here at Softcrylic, and have been had the pleasure of working with Nats and Sunder closely for the last few years, and especially with regards to today's event, with regards to the Analytics in a Day program that we've been running.
Hey guys, I am Nats Sivaramakrishnan, and I lead the application and data engineering practice within Softcrylic. And I have like about 19+ years of experience overall building apps and the data platforms for various different clients across various verticals. And I'm glad to be on this call and happy to help with any questions that you might have.
Hey everyone, my name is Sundar Sridharan, and I work in data engineering practice at Softcrylic. Like I help clients consume like clean, high quality data by building like data quality pipelines, and also like machine learning models for data anomaly detections. And I've been like kind of like driving this Microsoft based engineering practice at Softcrylic for a while now. I'm happy about it, like what Microsoft is bringing on plate for analytics, particularly with Azure Synapse and Power BI. It's the modernization of data infrastructure. It seems very exciting for me to work on this one, and I'm here happy to answer any questions that I can help you with.
Awesome. I think let's start out just what's an overview of Synapse and the capabilities that it possesses.
Okay, so Nats, you want to go ahead or?
Sure, I can. All right, so Synapse, in a way, it is the next gen analytics platform from Microsoft, right? So if you were to take a typical data platform, you have your data ingestion layer, you have your data transformation layer, then data store, and then finally your data delivery layer. And for each of these areas, we use different sets of tools. And also it is, with Azure Synapse, the biggest advantage is that it brings everything into a single workspace, right? So you can have your developers work from the same environment, the engineering team who does the data collection and data processing. Then you can have your data analyst work out of the same environment, and you can also have your data scientist work from the same environment. It just creates this ecosystem for everybody to come and work from a single place. And the benefit of using Synapse, sorry, I'm scrambling around here for my notes. 1 second. Vicky. Yeah, sorry, yeah. So the benefits of using Synapse is that you have your Synapse SQL engine, and then you have your Apache Spark engine, where you can either use both on-demand and or predefined workloads within Synapse. And you have your language choices. You can either use SQL, or you can use Python, or you can use .NET, Java, or Scala, or even R to execute all of your workloads. You can execute your workloads in both provisioned and serverless environment. And you get all your management, security, and monitoring and metadata store all out of the box, using Synapse. And it also like provides various different connected services, right? You can use Azure Data Catalog, then you can integrate that with Databricks. You can use existing HT Insights, and you can also get machine learning capabilities out of the box. For example, with Synapse, you can integrate or execute machine learning models using T-SQL statements as is without having to, implement separate Spark or, any other additional machine learning workloads. So these things make it easy for everybody to come into the single place and then start working on it. And the benefit of using Synapse, particularly for say data scientists, is that data scientists in the past used to have like a separate workspace, and that is not integrated with the enterprise data warehouse solution. But with Synapse, both of these come together, and data scientists can basically work on, it provides a platform out of the box for them to explore all the files, and at the same time, take those files out of the data lake and then join them seamlessly with the data that's stored within the enterprise data model and run any queries that they need to run. So it provides a lot of capabilities. It just basically assembles all the services that are available in Microsoft Azure under one unit, and seamlessly integrates them to give a unified effect for anyone who wants to consume, access that data for standard workloads or running ML workloads.
So if somebody had already made an investment with Data Factory and/or Databricks, should they migrate to Azure Synapse?
Not necessarily, right? Because Data Factory, you're talking about Databricks or Data Factory?
Either or.
Okay, so a lot of companies have invested in Databricks, and at this point, I wouldn't really ask them to migrate into a Synapse. But if there are, because Databricks is is here to stay, and Microsoft has already heavily invested in Databricks. But if at all there's any new workloads that the companies are trying to implement, then they could definitely look into Synapse, because a lot of these capabilities that are available in Databricks is also available in Synapse. It particularly is beneficial for companies who have already implemented a data pipeline, or sorry, a data platform in Azure ecosystem. It is seamless for them to migrate into Synapse because it makes it much more easier. But companies who have already invested in Databricks, they can continue to work in Databricks, but they can certainly integrate with Synapse, right? For instance, the data store can still be the data collection aspects, and the enterprise data model and data store can be managed within Synapse, and all of their machine learning models that requires any of these ACID capabilities can be maintained within Databricks, because with Delta Lake, there are some big time use cases that, within which Databricks fits in well. And so in those use cases, definitely, yes, Databricks can be used. And but when it comes to data collection and organizing that data and storing that data in enterprise data models, Synapse certainly can be used. And you also have capabilities to either execute Databricks workload from Synapse through their integrated services capabilities, or you can also execute Synapse workloads from Databricks using Synapse connector that's available within Databricks. So if you have highly complex transformation workloads that involves a lot of machine learning processes, then continue to use that within Databricks executed, but you can still have your data collection, data storage, and your enterprise data models in Synapse, and connect create interconnections between them and use the data.
Yeah, just to add to like Nat's point, like on Databricks, the question was also part of like Azure Data Factory. If you are already like, invested in Azure Data Factory, I don't think like, by default, like you already have Azure Data Factory as a part of Synapse Analytics. So you don't have to do any migration. You're basically like, you can take all your Azure Data Factory jobs and put it into Azure Synapse Analytics without any issues.
Yeah, thanks for clarifying, Sundar.
Definitely. So are there any main like glaring differences between Synapse and Databricks?
Yes, Databricks, the key difference in my view is the Delta Lake capability that comes with Databricks. And it allows row column level security and also asset transaction capabilities that can be executed within Databricks. And also until Synapse, a lot of the machine learning workloads, I think Databricks was much more effective to execute. But with Synapse, a lot of the capabilities that are in Databricks is available in Synapse. So you can, for any new implementations, unless there's a specific case of using these asset properties, you don't have to use Databricks. A lot of that can be managed within Synapse directly.
Yeah, I mean, just to add to more like to Nat's point, like Azure Synapse Analytics have two engines, right? One is the SQL engine, another one is like a Spark engine. So the major difference between Databricks is like Databricks is mostly like Spark, oriented big data processing. Within Synapse, you can bring in all of your SQL, T-SQL store procedures and T-SQL scripts, and then start like executing them within Synapse. So Synapse supports both SQL and Spark, big data workloads, and your SQL analytics can be in one unified environment. So that's a major difference.
Awesome. I guess maybe Corey, if you want to, we'll throw one more Power BI specific question out before we go deeper into Synapse. You're a Power BI guy. Can a Power BI source file based data directly from Azure Data Lake?
Oh, interesting. So, Nats was talking a little bit about, just the overview of Synapse, and certainly where the data viz team comes into play is sort of at the endpoint of all the engineering and being the sort of the presentation layer for all the work that's accomplished on the back end in Synapse. And so there's seamless integration there all the way through, and really, where Synapse and Power BI sort of come together are when we're talking about, enterprise scales of data that are not able to be cached effectively in Power BI's in-memory model. And we can maybe talk about that a little bit later on as necessary. But in terms of sourcing file-based data directly from Data Lake, yes, absolutely, that can be done. When we're talking about smaller scales of data that can be cached effectively in Power BI's in-memory model, we can bring the data directly from the Data Lake and pick it up and do all the transformation necessary in the Power Query side of the tool. And it's definitely an effective solution for smaller scales of data where we don't need that enterprise data model. But as data scales, those sorts of solutions, aren't going to have a great amount of longevity because they're simply data is going to outstrip the ability of the tool to cache it all in memory. And that's where the enterprise data model that Azure Synapse is capable of delivering to Power BI and capable of making available as necessary for those sort of reporting tasks. That's where that comes into play. Thanks.
Yeah, thank you. Awesome. We did just have a question submitted on our Q&A. If you guys want to try and tackle this one on the spot. Does Synapse SQL OnDemand support the TSQL objects like stored processes, etc.? Or is that in the provision SQL only?
No, I think it does support the execution of T-SQL stored procedures. The reason I say that is because the provisioning that we are talking about on demand versus provisioned is only for the compute resources, right? Not for the capabilities. So you have your database and you have your views there, you write your stored procedures and everything, but how do you want to execute that stored procedure, right? You want to either use a serverless compute resource, which can be provisioned on demand, or whether you want to execute within your provisioned environment with with set compute capacity. And so that's the differentiator. But I think yes, it can be executed on both environments.
I think you're muted. Okay.
Yeah, to answer the second part of the question, like a breakdown of what is feasible in one and what is not feasible in the other. Rather than asking the question that way, say if you have a workload like an data exploration kind of like a use case, it's better to use the on-demand SQL pool. But if you have scheduled jobs or frequently running workloads, it's better to use the provisioned version. So but in terms of capabilities, I think you can do use the SQL capabilities in both of them without any major differences.
Awesome. And Corey, we have something for you as well regarding Power BI integration within Synapse Analytics. Is there any advantage for this model over a separate Power BI service and getting data from the data lake?
So, absolutely. So again, the grabbing data directly from the data lake is only going to work so long as the scales of data will fit in the in-memory capacity of Power BI. And for pro reporting, that's going to be a gig of compressed data. For premium level capacities, we're going to be talking about 10 gigs of in-memory data models. And those are going to scale up over time. There's definitely growth on the product roadmap, but as there are going to be enterprise scales of data that far exceed that. And one of the things we talk about in analytics in a day is how do we scale up to sort of petabyte levels of data? And at that point, Power BI grabbing file-based data directly from data lake is not going to be our solution. So, but what Synapse does is it gives us one place to manage all these different sort of approaches to the problem. And so when we might use the file-based storage as sort of interim or a provisional solution as we're working, and whatever transformations that we develop against those file-based sources in Power Query, those can actually be lifted up into ADF jobs, correct, Nats? I mean, there's a way to import Power Query transformation all the way up into ADF now, right? With
Yes.
the data flows.
Yeah.
So we can use the transformation work that Power BI or Power BI developers have prototyped to serve as sort of the template for the enterprise data pipeline that will lead to that data model. But when our data scales exceed what is available in the engine, the in-memory engine, we talk a lot in analytics in a day about the hybrid data model in Power BI and about using in-memory caching for all of our aggregations, but maintaining a direct query relationship with the data on the back end for when we need to get into the most granular details. Thank you, Sammy.
Thank you. Good answer. I think kind of on a similar note here, what are the various sources from which Synapse can ingest data from?
So Synapse, I think there are two ways in which you can ingest data in Synapse. Right? They have this Microsoft Flow, data processing solution, which is mainly focused for citizen developers who could connect to various different data sources using drag and drop, GUI, and implement their workflows. So they have about 60 to 80 plus connectors, which includes basically any of the traditional databases that we have had, or CRM or SAP solutions. And apart from that, a lot of marketing connectors or custom data connectors that are certified by Microsoft. Like for instance, if you use a data wrangling tool, Paxata, then there's a connector for that, or any custom providers that are popular for data processing. Microsoft implements a certified connectors concept where you can write the connectors and then plug it in. So they have like about 60 plus connectors, right, for Microsoft Flow. Similarly, within ADF, they have like about 70 plus connectors within ADF to bring data from a variety of sources, which includes, again, the same traditional databases and other custom data connections. So I can post that URL in the chat window, and you guys can take a look at it. But yes, you can bring data in from a variety of sources using both Microsoft Flow or either through Azure Data Factory. Those are the options to bring data into Azure Synapse.
Yeah, obviously to add to that, like, if you have your data in SQL Server or, Cosmos DB or anything, it's just like a breeze to bring those data into Azure Synapse Analytics.
Yeah, thanks, Sundar. Yes, anything within Azure ecosystem, yes, you can directly bring that data in.
Thank you, guys. So we have another question regarding Power BI here. So the data model for Power BI can be created in Dataflow. So the data transformation can be handled in Dataflow instead of ADF. But the curiosity is to know if there's any disadvantage for using Power BI with Synapse.
Yeah, Prasant. So again, I'm going to go back to scales of data. So if their data is small enough that it can be stored in the within the memory limits of the data set in Power BI, then by all means, that's an effective approach. And so again, with pro data sets, they can be no longer than a gig. That's compressed. Pardon me, no bigger than a gig. And again, that's highly compressed. But still, it's very possible to exceed that. With premium data sets, they can be up to 10 gigs. But still, all of us know that when we're starting to work with enterprise sets of data, it's very easy to exceed those scales. And so when we are looking at building reporting solutions that need to account for colossal scales of data, a data flow is no longer going to be an effective way to handle that, because we need to have a SQL backend for that reporting when we start talking about petabyte scales of data. And so at that point, again, we're going to still use the in-memory model to cache our aggregations, so that the reporting on the aggregations are still lightning quick. But when we need to go to the most granular results with large scales of data, then we're going to direct query the SQL data model that is part of the Synapse solution. And we build this out during Analytics in a Day, and we actually do this with a lab data set. But it's exciting to see how well it performs and how well we're able to do Power BI reporting on vast scales of data. Thank you.
Yeah, thank you. Let's roll back for a second, just the idea of citizen data integrators. So if a semantic layer is built on Synapse, can citizen data integrators use Flow to use that semantic layer as a source to create tailored integrations?
Yes, absolutely. And but the idea of allowing citizen developers to create the workflow is like, I want to talk briefly about the various different data models that are currently being supported within Synapse, right? So you have your enterprise data models, then you have your BI data models, and you have your machine learning data models. So whenever you have to process data for enterprise data models, then going through ADF or the regular Synapse pipelines that's being offered is the best way to go, because you will have to process large volumes of data, and you will have to do a lot of data mappings and data stitching and whatnot. So that would be the best approach. But when it comes to BI models, where you already have your data processed, cleaned, and then set up in your enterprise data warehouse, and you need to extract data from there, and you need to implement your additional data processing rules to deliver questions that are coming from the business, where you have to work with smaller data sets, then in those cases, the Microsoft Flow is very useful. So this way, the data analyst, who would have to work on these questions doesn't have to rely on the IT or to change the entire data processing or change the enterprise model to answer those questions. So whenever there is a need or for flexibility to answer these questions quickly that's coming out of the business, then these BI data models are very effective. And in those scenarios, using a data flow is particularly very helpful to get those answers quickly to the business.
Definitely. So this question was submitted ahead of time before the event by one of our attendees / registrants. Can Azure Synapse help streaming data analysis? What are your guys' thoughts on that?
Definitely yes. And I will also post a URL around that on how that can be done. But yes, Azure Synapse definitely can support streaming analytics. And the way that it does is by using the streaming analytics services that's available in Azure ecosystem. So you either bring your data to Event Hub, your streaming data to Event Hub, or you're using your IoT service that collects all this data from various different devices, and then you channel it through your streaming analytics service within that's available in Azure ecosystem. And so that data can either then be pushed into your blob storage or is streamed into your Synapse data storage. Now, the benefit of using the streaming analytics service is that it also allows you to dynamically query all this data that's flowing through real time and investigate data. So it's extremely beneficial. But yes, and that's how you do it. So you will have to use that streaming analytics services, and then you can either directly push it into your Synapse warehouse, or you can either push it into your blob storage and then process it additionally to infer the metrics that you need to get out of it.
Awesome. If somebody was trying to adopt Synapse, how would you go about estimating the cost for a Synapse solution?
Okay, so Synapse is a collection of services that's brought under a single hub, right? So what it means is that you need to take into consideration the compute capacity for the data storage. So that is measured in data warehouse units, and there is cost for that. Then you have your data backups, data storage, and data snapshots. There is cost for that. Then you have your Spark engines that you would need to use to process large volumes of data. If in case you're using Spark and not traditional SQL, taking a traditional SQL route, so then you would have to, there's a price for that. Then there's separate price for the Synapse pipelines that you would use to ingest and process the data or execute any data movement activities. And if you are going to have any of your citizen developers be part of this data processing pipeline, then if they're using Microsoft Flow, then there's cost for Microsoft Flow. And then if you are using ADF separately, then there's cost for ADF. So because this is a collection of services that are brought under a single, hub, each of the service that's being consumed will have its own pricing model. It could be either hourly or based on the storage volume or the number of executions, depending on the service that we are using. So all those things will have to be taken into consideration before coming up with the total pricing structure for the solution that we are trying to solve.
Yeah, I mean, one big thing that I would add is like from like cost estimation standpoint, like basically like Synapse divides the pricing structure into like compute and storage. Like, so for the storage side, like, obviously, your storage can be a data lake or a data warehouse. Things that you're going to keep in your data lake, it's going to be cheaper. Cost of like storing data in the data lake is getting cheaper and cheaper. Similarly, like the amount of data that you're going to have in the data warehouse, it's going to have some cost involved on it. But from a compute standpoint, like there are like both on-demand and provisioned instances available, right? For on-demand, you can predict your cost a lot, but whereas for provisioned services, like you can definitely like predict your cost based on like the previous query workload executions and whatnot. And also like Synapse provides like a lot of like guardrails for you to prevent your users overutilizing the services. So you can actually like take your cluster, partition the cluster to specific departments. Like you can assign a particular cluster to your marketing or like to your like finance department based on like who needs priority. And also like you can set guardrails. For example, like if the cluster is being utilized a lot, then you can try to put in place like try to bring on-demand clusters when needed. So there's a lot of like options available in Synapse for you to like control the cost. Like Nats mentioned, like compute, like there are different types of compute. Even though there is a lot of unified services, different pricing models to it, but you have a lot of guardrails for you to like predict the cost and protect the cost, like rather than having a huge bill or something like that.
Yeah, thanks for pointing that out, Sundar. So one thing that I would like to add is that the on-demand versus provisioned servers, it's only available for SQL engines. For Spark, it's always provisioned compute resources if you are running Spark workloads. Please keep that in mind. And Sundar brought up a very good point as well. You can manage or allocate workloads based on groups. So for instance, you can, let's say you have multiple different teams and each of them are, racing for the resource requirements based on their jobs and priorities. So what you can do is like you can create groups within Synapse and you can define workload objects and then say like my sales team could get only 60% of the compute capacity and my analytics team could get like 40% of the compute capacity, which is actually provisioned. And so in this case, like if the analytics teams needs more compute capacity and the sales team is not using as much, let's say they are using only 40% and there's remaining 20% available, then depending upon the load that's coming from the analytics team, they could actually use that extra 20% that's available and then get their job done. But when the resources are full and completely used by all the users, then one does not step on the other's toe and then consume the resources, creating a gridlock. So this way, we can easily manage the resources effectively if we properly plan on how much processing is required by teams and by requirements.
Definitely. Do you guys have any idea how much percentage of cost savings people could assume if they were using Azure Synapse with other vendors?
Yes, there are some stats that we gathered recently from Microsoft. I can share that information here. I'm trying to find that. So 1 second.
And
definitely there's,
sorry,
go ahead.
Go ahead, Nats.
Yeah, I mean, what Microsoft estimates is that if you were to compare price per performance, like for instance, processing a set data, let's say you're processing 1 terabyte worth of data and then doing the same workloads across Redshift, BigQuery, and Synapse, using Synapse would be 25% less than Redshift, and also 94% less expensive than BigQuery. And now there's a reason for that, right? Because Synapse lets you do both on-demand versus provisioned infrastructure provisioning, effectively. So you don't have to struggle with either one or the other option. With Google BigQuery, the challenge is, like, for the most part, you are charged based on the amount of data that you are querying. And so they charge you like about $5 per terabyte worth of data that's scanned as part of a query. So if you have a large team, and if your data is democratized within the company where people are querying using that as a single source of truth to consume large volumes of data, then if their queries are all not optimized properly and all that, then Google BigQuery is going to scan large volumes of data unnecessarily, eventually costing a lot for the business from an infrastructure standpoint. And we have actually faced this problem in real time with one of our biggest clients that we worked with in the media space. So we had actually set up BigQuery to ingest a lot of log level data that's coming from multiple different sources. And that data that's coming in was shared across various different teams. And particularly, these are not like data engineers, they were data analysts who are trying to write queries, extract data, and explore the data, and trying to generate insights. And they were writing queries left and right, and their queries were not optimized properly. And in such a scenario, the company incurred huge volumes. They incurred a huge cost because BigQuery was scanning large volumes of data to generate those insights. Now, with then what we did is, like, we migrated a lot of that into Azure. And back then, Synapse was not available, but they had this concept called hyperscale database. So we moved it in there where you can manage, they allowed you to separate compute and storage. And with the provisioned setup, then the cost wasn't as high. We were able to control it. But with Synapse and the capabilities that it provides, particularly with workload management, we're able to bring in all that data, and we are able to create different groups and allocate resources to them. So, the teams would have to operate within the resources that are allocated, and this significantly controlled the cost for the users.
Hey, Nats, on the opposite end from that, there's a reason I don't sit on the engineering team, right? I know just enough to be dangerous, and my talents are in other places. But is there a lower limit where, like, projects can be too small to be effectively used in this platform? Like, I know the promise is to start small and scale effectively, but is there a lower limit where you would say Synapse is not the right solution?
No, not necessarily, because you can scale as you go, right? To begin with, if you have a smaller data set, you can have a data warehouse set up with one node and with a lesser capacity, and still continue to use all these amazing capabilities that comes out of the box with Synapse. And you are not going to be charged an exorbitant amount of data cost, because if you are processing a lesser volume of data, then the resources required to process all that data is going to be really less. Like Sundar pointed out, your cost is primarily split between storage and compute. And so the larger the volume of data that you process, then your cost is going to be comparatively higher. So, you will not be, it's not going to be expensive for you to start small.
Excellent. Great. Thanks, Nance.
One thing is, like, Microsoft kind of suggests, like, if you're focusing on the Synapse data warehousing standpoint, if you have a data of like 50 plus GBs, it's good to start there. That's what, like, they're suggesting, but you can go lower than that as well.
Awesome. And then we have a follow-up from Rajesh from the use case you mentioned, Nats. He's wondering, is the idea that you spin up a cluster to carry out the compute, load the data into it, carry out the compute, and then spin it down, leaving provision compute up and running would assumedly be cost prohibitive?
Yes, and what you can do in those scenarios is like once your work is done, then you can definitely pause your resources and not consume it, and then bring it back up as and when needed, and use your on-demand resourcing to process the data.
Great. For the tool, what kind of monitoring and security capabilities does Synapse have?
Yes, they actually have a lot. So out of the box, Synapse provides threat protection. So they monitor any incoming requests, and they provide like DDoS support for detecting DDoS attacks or any other SQL injections or any other types of attacks, right? That comes out of the box with Synapse. Then they provide extreme network security. So you can either use Azure's virtual networks and bring the Synapse solution within that virtual network, and you can set up your firewall, and you can also use Azure Express Route and then set up dedicated lines between your infrastructure and the cloud, and manage it there, manage access based off of that. And also you can integrate the Active Directory services and enable multi-factor authentication to enable access. So this way, you don't have to manage two separate logins for users if they are in your company's Active Directory services, or having like a Microsoft Office 365 account. Then all that can be integrated into Synapse out of the box, and those users can be those access can be enabled. Access can be enabled for those users within Synapse. The other biggest benefit with Synapse is that you have two different types of data stores, right? You have your data lakes, and then you have your actual data warehouse. Now, we all know, like with data warehouse, we are able to give that granular granular production, like row and column level security or table level security. With Synapse, even within the data lake, you can use the same credentials, and you can create groups, and you can say like users can access specific containers, specific folders, and specific files within that, and you can get to that level. And it provides great flexibility there, which was not available earlier. And within the data warehouse side, it provides row level security, column level security, which is a standard thing in a SQL servers that we have seen in the past. But one thing that's coming out of the box with Synapse additionally is the dynamic data masking capability, where you can go in, select table, and then select the columns, and then mask that data dynamically, and allow the data to be accessible only to specific groups or users, which is very, very valuable. And in our implementations, that has been like the setup of that process has been really a breeze. Then it logs any access that's it logs everything, right, that happens in the server, and so it allows us to do auditing on the data or the access to the data that have happened. And you can also like provides vulnerability assessment reports out of the box. And all of this is coming for free, right? You don't have to pay anything to use any of these capabilities. All you pay for is your storage and your compute costs, and all of the features that I talked about now all comes for free for Synapse users.
Yeah, in regards to the monitoring system, monitoring like features like within Synapse, like you have like the monitoring hub, which is basically a place where you can monitor all your data factory jobs, and they provide like email notification alerts, and then also like they provide a lot of like features that allow you to pinpoint like where exactly your job is failed. So you have like you have also like some lineage graphs where you can go and find out like if the problem is with your data connector or things like that. Particularly if you guys are joining us in our analytics in a day workshop, like you will have hands-on experience with Azure Synapse Analytics to look at like the security features that like Nats pointed out, like dynamic data masking, and also like monitoring features, like how you can debug your jobs in such a way that you can go to a data source level and see like where the problem is.
Definitely. Now, as we're kind of starting to round the corner of our hour, we probably have time for a couple more questions. Ramesh is curious. He's heard a lot about performance issues while loading huge data into Azure Synapse. Is that a true statement?
So you can load data into Synapse, using two different ways. Actually, three different ways. You can use your ADF, and you can use copy activity within ADF to load data into Synapse, or you can set up your Polybase and create an external table and load data into Synapse through Polybase. Or Azure has now come up with the copy command that can be used directly into Synapse. Now, Polybase is the fastest option to load large volumes of data into Synapse, but the setup process is a little cumbersome. The second best option that we have right now is copy command, where you can simply write a SQL statement and then point your source in blob storage or in your ADLS, and then provide your identity mechanism, and then provide the file type, and then it just ingests the data into the table. Now, from a performance point of view, there are various things to consider. So if you are using a CSV file compared to a Parquet file, then there's definitely going to be a performance impact. So we recommend Parquet files generally, and we have seen faster load times with Parquet files. Also, the benefit with Parquet files is that it also provides faster querying capabilities when you're trying to query data directly from a file using SQL engine from Synapse. So it depends on what the size of the file is. There are also other best practices that we need to follow when it comes to sizing your input file based on the resource capacity that is set up for the ingestion. For instance, if your compute capacity is being shared across multiple different workloads, such as data delivery, data processing, data ingestion, and if it's not being planned properly, then you are going to run into that issue that you just talked about, Sami, because there's also always going to be race for resources from various different services. And so we need to plan that out well to get that overall benefit out of Synapse when it comes to data ingestion.
All right. We'll have two more questions here, and then we're going to wrap up for the hour. Going back to privacy concerns, how is it possible to implement data governance and GDPR policy for Synapse?
So Synapse has tools and capabilities, right, for us to be able to implement a lot of these policies that's enforced by the government, right? But how we do it is within us. Now, with the capabilities that they are providing around data protection, access control, authentication, network security, and threat protection, and the dynamic data masking, we need to basically go through the guidelines in detail, and we need to orchestrate the security setup accordingly. So there is, at least based on my experience, there is no out-of-the-box solution for setting up security parameters for any of these policies in any of the systems that I've worked with. So, I mean, it's not like a flip of a switch wherein you say like, okay, enable GDPR guidelines here or CCPA guidelines, stuff like that. But in our experience, we carefully go through all the guidelines that they provide, and then we set up the security based on all these features that are available out of the box in Synapse. And that's the best way to do it.
Awesome. And then we'll close out here. So BigQuery allows logging of all ad hoc queries and provides detailed metrics on them. In terms of cost, resources used, data scanned, etc., does Synapse offer this capability as well?
Synapse, like Sundar pointed out, Synapse does offer the monitoring capabilities that provides details around who used what information. But here, most of the resource utilization is on the provisioned use case, and most of the resource utilization is around the provisioned resource infrastructure that's been set up. So as of now, I think we don't have that facility like what BigQuery provides, and I can certainly look into it and then get back with an answer for that question. But I have not seen any reporting from Synapse like that.
Yeah, one point is like Synapse is a new product, like still some of the features on GA, but like, yes, Synapse will keep on adding features with the competing data warehouses like, BigQuery, Snowflake, even some of like, the Databricks competitions. So definitely features will be, Microsoft team is like, adding a lot of features to Azure Synapse Analytics.
Awesome. Thank you guys for all being on our panel today as subject matter experts and going through all these questions. We'll definitely be doing a follow-up event probably closer to the new year after all the holidays pass. If you have more questions about our services, anything like that, you can reach out to us, info@softcrylic.com. But with that being said, thank you guys. I think you did a great job addressing everything. It was a pleasure to moderate this for you.